Okay, so I want to show you today we're going to start looking at triangles and their congruence. Okay, so we're going to start looking at the congruence of triangles. And we spend a lot of time these next little bit talking about triangles. I think I mentioned for you before, the reason why is because the triangles are one of the shapes that has the strongest support. So you see bridges made out of triangular sort of shapes. You can think of a tripod, triangular at the base. Okay, so there are different types of examples of why triangles, roof structures are sometimes triangular. Triangles have that strong sense of support. So that's why we spend a lot of time talking about them. So the congruence of triangles, you're going to use a GeoGebra document for that, but before you do, let's talk about a little bit about this congruence of triangles. First of all, the definition, because we never really defined what congruence is. So the definition of congruent means same size, same shape. All right? So if we say two things are congruent, that means they have the same exact size and they have the same exact shape. That's what congruent means. All right? When we're talking about congruent triangles, particularly, okay, they're going to have the same size and same shape, but there is a correspondence to them. Congruent triangles and their correspondence. So, for example, if we say that triangle ABC is congruent, that's the symbol for congruent, equal sign with a squiggly over it, triangle DEF, then the correspondence is for congruence would be, first of all, we have these triangles, and we would mark A is going to go to D, we're going to mark those, B is going to go to E, mark those, and C will go to F. Then we would have sides, so AB corresponds to DE, BC corresponds to EF, and DF corresponds to AC. So there's our congruent parts in the triangles. So angle A congruent to angle D, angle B congruent to angle E, and angle C congruent to angle D. Or not angle D, but angle F. And the sides, AB congruent to DE, BC congruent to EF, and AC congruent to DF. So those are our 6 corresponding parts when triangles are congruent. All right. So what we want to do is explore this triangle congruence idea and see, do we need to have all 6 of these things to be congruent in order to say that the triangles are congruent. All right, maybe we don't need them all. Maybe we could just use 2 or 3 parts. And if we had 2 or 3 parts, then we could say, well, all the rest of them follow through, and then the triangles are going to be congruent. Okay, so that's the whole idea, is we want to know how many different parts, corresponding parts, have to be congruent in order to make the triangles congruent. That's our big thing. So we're going to use GeoGebra, but we're going to use on my website. So let's go to the website here. Here. Oops, that's not the right one. Okay, let's go to okay, so we're going to go here. And on to Unit 3. And we're going to check out Triangle Congruence Part 1. Okay, so let's explain a little bit about what this does. All right, so it says each GeoGebra window has 2 triangles drawn using the same corresponding parts that are congruent. If possible, change the triangles so they are different in size and or shape. If the triangles are congruent, use the text box to write yes. So the very first one we have is an A=2 slider. I marked the side that corresponds with the slider. All right, so you can slide this around. Should be able to. I don't know why mine's not sliding. Yours is probably going to slide. Well, mine's not sliding. I'm not sure why, but I checked it out on a different computer. So this will slide. So you can slide A, and it will move around, okay? And that will change these triangles. But the idea is we want to know, are these 2 triangles congruent? Well, it's pretty obvious to see that they're not even the same shape. All right, so this one here definitely looks different. All right, nothing is moving here. I don't know why. That could be a pen issue with the tablet, but either way, we can see these 2 triangles are not congruent. So we're not going to say anything to that effect. We know that having one side congruent isn't quite enough. So these triangles are not congruent. All right. Then you would move down to the next one. Oops, and check that out. Now this one has 2 angles. All right. So we have an angle here and an angle here. All right. So you can slide that around if you want to, but it's just keeping these angles the same. The question is can we move this triangle so that the triangles change and they are not congruent? So that's what you should do. You should check to see by moving those triangles around, if they're not the same shape, if they're not the same size, then they're not congruent. All right. So this is kind of a difference between what we call static geometry, which is what dynamic geometry, which is what we've been doing with moving things around, and static geometry when nothing changes. All right. So you're going to run into some static geometry types of situations. So work through this triangular congruence part 1. Check to see if there's anything that happens as far as keeping the triangles congruent. Then go and do triangle congruence part 2 and do those ones. All right. So you're going to have 8 different situations. This will take your time, go through it, all right, because it's important that you see when the triangles are staying static. In other words, they're not changing as far as what's congruent, okay? Or they're being dynamic. In other words, you can change one of them, but you can't change the other one is staying, so that they're different shape and a different size. So if you can change one of the triangles, right, and the other one doesn't change along with it, then they're probably not going to be congruent. Okay. All right, try that out, and we'll see how that works. Hopefully I can get this to work when we come back. Okay, so you should be able to see what I'm doing here using the computer. So here's the first one. All right, and we see that these triangles are one angle, but they're not the same size. It's obvious to see that. This is not even the same shape as this one. So one angle, or excuse me, one side length doesn't work. So hopefully you got that part. What about two angles? Let's try that out. Okay, so here I can adjust this, right? But the question is can I adjust these triangles? So I can adjust this triangle, and I can adjust this triangle, and obviously I can see that no matter what I do with these angles, it doesn't really matter how I arrange those, these triangles are not the same size. So two angles is not enough to give me congruent triangles. They are different size. Next one is this one. Again, I can change that angle. I can change the length. So this is a side length, all right, here, and an angle down here. All right, and again, I can see that I can change this triangle, all right, so it's not even close to the same shape as this one. So we're striking out when we have a side length and an angle. That doesn't seem to work. So we had just an angle, or excuse me, we had just a side, we had two angles, a side and an angle, and finally we have two sides. What if that works? All right, so there's the B, there's the A, all right. These should be color-coded, but they haven't, they're not there. They will be on yours because I'll go back and fix that. But again, it's easy to see that this one here, see how that triangle doesn't change? And now it does. But it's still not the same shape as this one over here. So it's taking more than just two things in order to make triangles congruent. All right? That's not working out. Okay? Even if I adjust these, it doesn't make any difference. These triangles are not going to be the same or congruent. So let's do the next one. So I'm going to go and get the next one. Okay, so I come down here to 3, and I'm going to get part 2. Alright, now I have part 2. Same directions as before, right? We want to check to see if this works. Now here we have 3 side lengths, alright, and the colors are corresponding to them, right? Green, purple, red. I can change this if I want to. Oops. Now I have to be careful that I make sure that these form triangles. Okay, so it's possible that they don't. Remember, we talked about that a while ago, that certain side lengths, combinations of, will not form triangles. Alright, here's this. Alright, good. But are these triangles always going to be the same? Well, this one here I can't adjust. This one here I can't adjust. And this here I can't adjust. Same thing here. Right? So no matter what happens here, I can't adjust these triangles. And they look to be the same shape and the same size. The 3 sides we know are the same because this is all 5, 5. So let's change it to something different. So all 3 side lengths, now it's scalene, but still, right, these triangles are not the same. Now, if possible, let's see if we can arrange this. Let's see if I can tilt this thing, just spin it a little bit. and you could see how those side lengths correspond. Now, let's see if we can take this guy. Oh, let me see if we can take this. Aha! That's what I want to do with it. And slide it. Oh, can't quite get it. I have to reflect it to get it to work. So if I reflected this triangle, we could see that it was going to match up perfectly with this one here. Alright, and that they would be congruent. We should be able to do that with some of the other ones. But if we wanted to, we could reflect this triangle and get it to match up the same. Alright. So we just take a little reflection there. Okay, so these two triangles are going to be congruent. So on our text box here, we should have said yes. Alright, so we come down here to the next one. Here we have a side and an angle. There's our angle right there. So we call this a side angle side arrangement because we have a purple one here, a green one here, and the angle. Again, let's see what happens. That one doesn't move. That one just moves a triangle. That doesn't move. That doesn't move. So these triangles, and just with a little bit of work here, they match up perfectly. You can see that. So these triangles are definitely going to be congruent again. Right? No matter, even if I change the side lengths, all right, and I still form triangles, they're still going to be the same. So now here on this one, I would put a definite yes. All right, say okay. All right, get down here, try this one out. This one here has an angle, a side, and an angle. There's my angle, there's my side. All right, I want to see if these triangles, again, I'll try moving it, changing its shape, doesn't work. Look at that, they match up. So these triangles are also going to be congruent. I think we're starting to see stuff here. So this one's going to be a yes. All right, so this one's yes. So hey, everything must be yes, right? With three of them? Well, I don't know. Now here we have three angles because we have these two, and if we have these two, then automatically these have to be 180. Okay, so there's my angles, there's my angles. The question is, oh, look at that. I can definitely change this triangle so that it is a different size. All right. Okay, so those triangles are not. So angle, angle, angle does not work. Here we have an angle. Let's see, we have a side, angle, angle. So in this case, we have a side and an angle and an angle. There's the side. Here's the angle we can adjust. We can adjust this angle. The big question is can we adjust the triangle? That one doesn't, just rotates. That one moves up and down. Rotate, move up and down. Let's see if we can get it to move right on top of one another. Look at that. All right. So these triangles are also going to be congruent. All right. So what we want to do now is let's look at which ones worked. Okay. So at the very top, we had a side, side, side. So we call that side, side, side because we have three equal sides or congruent sides, right? So that one worked. So I'm just going to put down here, I'm going to put S, S, S. All right. Let's check this one out next. This one is a side, an angle, and a side. Okay, so for this I would also put down S, A, S. My next one is a angle, side, angle. And that one worked. This one was angle, angle. It did not work. And finally, we had a side, angle, angle, and that one worked. Oops, there we go. So the angle, angle, angle didn't work, but the side, angle, angle did. Side, angle, angle. Okay, so those are the ones that work, all right? So our triangle congruence conjectures. Side, 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 angle, side, angle, side, angle, and side, angle, angle. Those are the ones that work, okay? The ones that do not work, remember, were angle, angle, angle. That one's a no. And there's one other combination that we haven't looked at yet, okay? And we're going to take a look at that one. Probably not today because I can't get the darn thing to work very well. So we'll set that one up, and I'll show you why that one doesn't work. Probably on Friday, okay? So how do we use this, right? Here's some of the problems that we're going to be looking for. The question is going to be, are these triangles congruent? Are these triangles congruent? If so, state the congruence conjecture and write correspondence for the triangles. All right, so this is what we're going to have, all right? We're going to have a triangle like this. I'm going to mark this side here, and I'm going to mark that side there, okay? I'm going to mark this angle K, I'm going to mark this angle U, I'm going to mark those two sides right there. So, I'm looking at these triangles, and I notice that I have a side, an angle, and a side. Side, angle, side. So I look at my conjectures. Sure enough, side, angle, side is one that works. So are these triangles congruent? The answer is yes. State the congruence conjecture, side, angle, side. And then we're going to write down how they're congruent. So we're going to go like this. We're going to go triangle KAT, congruent to triangle. K corresponds to U. A corresponds to T. And, oops, we can't have two T's. We'll call that one C. A corresponds to C. And this T corresponds to that B. So that's how you write the congruence conjecture. It helps to have these two marked, okay? KA, UC, KT, UB. All right? So there's one. Pause these at any time. That would have been a good time, maybe. All right, let's do one like this. This one's called the old bow tie triangle. All right. Same thing. We want to know if these triangles are congruent. But second, we only have two sides, right? We need something else. We just can't say things look like they're congruent because that's not, if it's not marked, we can't say it. But here's what we got. Right here, vertical angles. We know those angles are equal. So now we can say, oh, side, angle, side again. So yes, I'm using purple here, I forgot. Side, angle, side. All right, so if we go triangle, all right, C-O-N, congruent to triangle. C has a double mark here for that side, right there. Double mark here, so I'm going to go down to R. O is on here, that's going to go to L. And N is in the middle. Okay, side, angle, side. Let's try another one. Okay, here's one like this. Okay. Again, we want to know if these triangles are congruent or not, right? Well, shoot, we only got two sides marked. We don't have anything else, though. However, look at this triangle. As we look at this, we see that this triangle up here and this triangle right here, as I trace them, I notice that the red and the green sides in these two triangles are shared. In other words, they're the same thing. So that means I can put my third mark through that, right? Because those two triangles, they share a common side. So now we have side, side, side. So yeah, these triangles are congruent. So the answer is yes. And we'd say why? Because of side, side, side. And now we're going to write this out. Triangle ATL congruent to triangle. A has a 2 and a 3 side mark there. This triangle has a 2 and a 3 mark, so it must be L. T is obviously going to go to Y. And this L, all right, and the red one has 1 mark and 3 marks, so that must go to this A over here. So that's the correspondence, all right? One like this, one like this. Okay. So let me mark some things on this one. All right, here we have an angle and two sides. So angle, side, side. Here, I have a side, angle, side. So in this situation, we have two triangles with sure the same parts marked. We have two sides and an angle. But here, we have also two sides and an angle, but they're not in the same order. All right, so that makes a difference. So when we have an angle side side and a side angle side, those are two different arrangements. So that means they can't be congruent. So the answer to the question is no. And because they have different arrangements of angles and sides. So those triangles are not congruent. All right. We're going to give you some problems to play with a little bit to get these. And the plan would be to kind of talk a little bit more about this on Friday, see kind of where you're at with it. Hopefully the video thing turned out. and have a great day. I'll see you on Sunday, or sorry, on Friday.